Please, inviting our distinguished panelists, Shri Puneet Dubey, Director Technical, MPP KVVCL. Warm welcome, sir. Shri Anil Rawal, Managing Director, IntelliSmart Infrastructure. A very warm welcome to you, sir. Inviting Shri Puneet Chabra, LTech Inc. USA. Warm welcome to you, sir. Inviting Shri Amarjeet Kumar, India Representative, Vice Sun Alliance. Warm welcome. Inviting Shri Ravindra Desai, Program Manager, IEEE ISGF. A very warm welcome to you, sir. Inviting Shri Pramod Mishra, AVP, Head Distribution, Planning and PMO, BRPL. And also inviting Shri Sabhadeep Ray Chaudhary, Head Engineering, Equipments and Networks, TPDDL. Warm welcome to you, sir. Namaskar and good morning, ladies and gentlemen. It is my pleasure to welcome you all to day 2 of the brainstorming event by Central Electricity Authority on the occasion of the CEA Golden Jubilee celebrations. Today, we focus on a crucial topic for the future of India's power sector, that is smart distribution systems. Our session today will dive into several key areas, including leveraging smart meters for digitalization, emerging technologies in distribution, hotline maintenance, and the role of communication and digital technologies in supporting renewable energy and electric vehicle integration. And to set the tone for today's discussion, we have with us Sri Hemant Jain, member CA for the context setting. Sri Hemant Jain has work experience of almost 33 years in various facets of power sector and is presently heading the grid operation and distribution wing of CEA, which comprises of the 5 division and 5 regional power committees, each headed by a chief engineer level officer. After his initial stint as assistant director in grid management division of CA, Sir was amongst the few officers deputed by the Ministry of Power to the newly created Central Electricity Regulatory Commission CERC in 1999. In CERC, he had handled the work related formulation of Indian Electricity Grid Code, regulation of interstate transmission of electricity, including licensing and tariff setting preparation, and notification of related regulations. Sir's experience in grid operation and distribution planning will certainly provide valuable insights as we discuss modernizing India's distribution system. So let's put our hands together once again to welcome Shri Hemant Jain, sir, for the context setting. Over to you, sir.
Slides also change करूंगा. Yeah, Shubh Prabhat and Namaskar to everybody. Distinguished professionals on the dais, esteemed guests, colleagues, and dear friends in the gathering. I extend a warm welcome to you in the morning session on smart distribution system. I know it's difficult to come up in the morning and join the session. Uh, Thank you very much for joining. And it's my honor to address this August gathering. Uh, as we are just aware that distribution sector is gradually becoming a dynamic and a vibrant sector. We have had enough uh, reforms, and I would say the development which has happened in the generation field of generation, transmission, distribution has also evolved. But I think the in that the present juncture, it is a distribution which will have to drive the power sector. I'll just take you through a small presentation, and then I would like to say that our panelists, distinguished panelists, they would be giving you more insights on the subject. Uh, If we look at the journey of India's power sector, like we are well aware that we have moved from a power deficit situation to now we are in a situation where we have been able to meet a peak demand of 250 gigawatt this year. And I thank all each and every stakeholder who have been a part of this support uh, to the system for meeting this demand. And in fact, we all agree that the integrated national grid, Indian grid, is one of the most uh, unified power grid in the world, and its integrated operation itself is a challenge. When I would like to thank all the system operators, maybe from the generation side, from the distribution side, the grid operators, the transmission side, and then the generating resources who have really put in their efforts to see that where we stand today as we have evolved. Uh, just to take you through that, there have been key, though its distribution is a concurrent subject, and we say that it is mostly the state which have to take lead on that. But nevertheless, central government of India has always been at the forefront to see that the distribution sector is given its due attention by formulating initiatives which are implemented across the board in the country, some of which have been Deen Dayal Upadhyay Gramin Yojana, then Integrated Power Development Scheme and Saubhagya Scheme. Uh, with the implementation of this scheme, which have since been implemented, now at least we can say that we have universal access to electricity in our country, and that I would say it has been a very big step where at least every household stands connected for availing electricity, and that is how that is how the living standard and the economic development has taken place in the country. The way we have progressed, uh, if we if we look at the achievements in the distribution sector during this journey, has been that now we have at least the urban rural areas, the supply has improved to 22.5 hours, which was around 12 hours in 2015. And in urban areas, it's almost 23.5 hours. So it's almost round the clock on a daily basis. The aggregate technical and commercial losses, which have been the most talked of topic, in fact, they have come down significantly from 24.62% to right now 15.37% in 22-23. So there have been investment which has been made by central government in the past schemes, that is around 2.4 lakh crores. And this has strengthened the power distribution system to a large extent. Now, with this level of AT&C loss, the next thing what has to be achieved can be by technical interventions. And that is what I say that today's session is primarily focused on that. Uh, Everybody would agree that uh, smart is a buzzword today, and so we talk about smart distribution system. Now, the first thing is that what has been observed in the distribution sector, that was that, like, whether the energy which is being consumed, that is being accounted for, and that is what we are looking at with the deployment of smart meters. Yes, the important thing is that the energy is not only to be accounted, but it has to be analyzed, and that can be one way of of looking at as to how we can improve the supply chain, and what can be the efficiency which can come in. Now, this has a direct correlation if we look at the net zero carbon target, which we have kept for 2070. Now, if we are able to improve this energy deployment in the distribution sector, so probably the resources which are required to supply electricity to all, that also gets impacted. And that is an optimal utilization what we are looking at with the smart distribution system we are talking today. Now there have been initiatives on the now then about smart meters. Then we have smart meters are associated with the advanced metering infrastructure. We are also envisaging the prepaid metering system. In fact, that improves the cash flow position of the discoms. And then we are looking at the smart level metering, system level metering, which is at the feeder and the distribution transformer level. Now, all these things are meant to improve the operational efficiency and the financial viability of the distribution companies. Uh, the recent launch, which has been done by central government of India, that has been the RDSS scheme, revamped distribution sector scheme. And the focus is basically again on the improving the operational efficiency and the financial sustainability of the discoms. Uh, the scheme has set a target of reducing the AT&C losses to a pan India level of 12 to 15% by 24-25, and to reduce the gap between average cost of supply and average revenue realized to zero by 24-25. Now, this would definitely depend on the technological interventions, where the deployment of smart meters, the digital tools of AI and machine learning are being envisaged for better accounting, predictive maintenance, and then the loss reduction. We have The government of India has already sanctioned projects worth 1.46 lakh crore for loss reduction program and to improve the overall distribution infrastructure. The future focus, I would say, will be on AI, machine learning, and digital twins, about which our learned panelists would be sharing their insights. And what we would be looking at, and I would request all my panelists, fellow panelists, uh, what we'll be looking at is really the roadmap for deploying these technologies. And we need to appreciate the fact that all the distribution companies are not operating at the same level. So there has to be some hand holding, there has to be some capacity building, and the roadmap has to be in a way that we are able to take everybody along. That is how we can look for a robust distribution system, and in fact a robust Indian power sector. About the future focus, the present session will also discuss about uh, the modernization of the distribution infrastructure, then about the communication technologies, because that is the prime thing which will drive our entire distribution methodology, I would say, in the coming years. And most importantly, rooftop solar, which is coming in a big way, and for which Honorable Prime Minister has already launched a program, massive program. Now, with this, there are two, three other interventions which are coming in. One is vehicle to grid, V2G, and then we are looking at battery operated our transport vehicles, buses. So that deployment needs, you need to have a high capacity charging infrastructure at basically they will be in the urban areas and they are congested areas. So that itself is a challenge uh, on which I think our one of our fellow panelists would be speaking. Now all these things, then we come to what it would mean is like if when we are looking at a power supply of round the clock basis 24 hours, then comes the importance of the preventive maintenance and predictive maintenance. Now here the importance of hotline maintenance comes in, because the fact is that for maintenance we cannot envisage that the supply be cut off. We have essential loads which are to be met, and I think this is what we are going to introduce in this session about hotline maintenance. It's a practice which has been followed for the transmission network, but we need to extend this to the distribution network itself also. Now, the success of our entire effort would be a direct collaboration between the stakeholders, between the consumers, and the policymakers. What we are looking at, and what I would request amongst our gathering, we have esteemed people who have been working in the power sector. What we are looking forward is that please feel free to contact me and my entire team in CEA, along with my CA management also. Please feel free to give your suggestions as to what are the likely policy interventions which are required. And at the same time, there are Central Electricity Authority regulations which are in place. So possibly some regulations would also require amendment. And I would request all of you to please feel free to communicate to us your views as to what type of interventions would be required. But at the same time, let us appreciate that what CA as a statutory body is doing is basically looking at the interest of all the stakeholders. So what we have to look at is, at the same time, we also know there are financial constraints for the discoms. But here it is, I would say, Government of India is making all out efforts, and at least the fund release from the Government of India is not a constraint at present. So that's we can only request the utilities to come up with their project reports for funding under RDSS, and we have been requesting all the utilities in this regard. So again, I will use this session and use this platform to urge all of the distribution utilities who are and the person and the officials who are present over here to please submit your detailed project reports regarding the under for funding under RDSS, and we'll be too willing to examine it and clear it at the earliest. That has also been a request which has been coming from Ministry of Power also, and we are also making a similar request. Now, just a small thing, because I think I have got my learned panelists over here, so I would simply try to close uh, by saying that what we are looking at is optimization of the power sector resources, and that will go in a long way to our envisaged path of net zero by 2070. Technology, yes, it has to play an important role, but at the same time, the technology for implementation of these technological interventions, we need to have adequate capacity building for our personnel who are in the distribution sector. And RDSS itself has a component of capacity building, which can very well be utilized for this purpose. One more request would be that we have been seeing that our Government of India schemes, they have to be communicated to the consumer level. So unless we make consumers aware of the programs of Government of India and what are the likely benefits which are going to accrue, I think the success will not be to the extent we are looking at. So my request to the panelists, to the gathering over here is that whatever programs Government of India or the state government or the distribution utilities are envisaging, it is very important to communicate to our ultimate consumers the benefit which is going to accrue to them. Because sometimes there are some preconceived notions which do derail our programs. I think that will be one important thing which I would request everybody. And the roadmap which I am requesting requesting my panelists also, r- roadmap for these technological interventions have to be basically a little realistic, looking at our ground condition, looking at the fact that all the distribution utilities are not identically placed, and hand holding would definitely be required in most of the cases. So let us try to frame our program on with these contours. And thank you very much for your patient hearing. Namaskar.
Thank you. Thank you very much indeed, sir, for the context setting and for providing a comprehensive overview of the opportunities and challenges. But before we move ahead with the panel discussion session, we would like to play a short video message by Sri Gansham Prasad, Chairperson, Central Electricity Authority.
CA completes 50 years of journey in the power sector. As we look towards 2047, the centenary year of India's independence, we envision our nation emerging as a global energy leader. This transformation will be driven by a shift towards a cleaner, more diverse energy mix that not only fuels economic growth but also aligns with our climate goals. The coming decades will witness transformative changes as we strive to meet the growing electricity demand, integrate large scale renewable energy, and strengthen grid connectivity. This will require coordinated actions on expanding our generation capacity, investment in new technologies, including energy storage, as well as modernization of infrastructure. Equally crucial will be the enabling pillars such as innovative financing, cutting-edge R&D, skill development, and creation of forward-looking regulatory frameworks. At the Central Electricity Authority, we are fully committed to leading this energy revolution. Ever since its inception, CA has played an integral role in the development and regulation of India's electricity sector. As we embark on our journey towards a developed economy by 2047, we'll continue to chart a clear path for a sustainable and future ready power sector. I wish CA a grand future ahead in charting out a journey towards 2047.
Thank you very much indeed. I now hand over to our session moderator, Shri Reggie Kumar Pillai sir, President ISGF, to kindly carry forward the proceedings of the panel discussion session. Over to you, sir.
Respected chair, distinguished speakers, experts, and delegates in the audience, welcome, good morning, and welcome to this smart distribution session. As you all know, power sector globally has changed in many ways in last 2 decades. Nobody could imagine even 10 years ago what is happening today in the power sector. In 2004, the, across the globe, we installed 1 gigawatt of solar power. Last year, many days we installed more than 1 gigawatt. And this year, most of the days we will be installing 2 gigawatt with a target of up to 670 gigawatt of solar generation addition in 2024. And as more and more of generation resources are getting connected to the distribution end of the grid, the low voltage grid. With that, the traditional boundaries between generation, transmission, and distribution is fading. The grid is evolving as a integrated and smart grid. India, nobody could think of that we'll have this kind of a change in such a short period of time. We have electrified all the villages, all the households, and 24/7 electricity is the next major government program which you heard yesterday today. Our current generation capacity of 454 gigawatt, the target for 2047 is 2100 gigawatt. We are talking about 5 times. Globally, there are about 9 terawatt of approximately 9 terawatt of power generation capacity connected to the grid, and all estimates talks about filling that in next 3 to 4 decades. Reason: more than 140 countries have pledged net zero target varying from 2045 to 2070. And the main philosophy of decarbonization is electrification. You are seeing the transport sector getting electrified, agriculture getting electrified, and according to the latest estimate of BNEF, about 2 billion machines, 2 billion machines that are today run on fossil fuel will get electrified in the next 25 to 30 years. And that is what is going to make the power generation much more demanding. And to evacuate the new power plants, which we are going to, as I said, globally it's going to triple. In India, it may be 4 times. We need to build more transmission and distribution lines, which is estimated to be about 80 million kilometers of new transmission and distribution lines at an investment of $21 trillion. These are the latest numbers. So that need to be done in the next 25 years by 2050. So what we did in 130 years, we need to replicate that in the next 25 years. It's a huge challenge and a very, very interesting times. All new technologies which you can talk about. You heard from Jane Saab's presentation, artificial intelligence, machine learning, robotics, all of them have applications, real life applications in power sector in every part of the world, including India. As you know, we, a bold program we initiated 2 years ago. It's about 100% smart metering for all the customers. 250 million smart meter rollout is going in a big way, and about 130 or 140 million of them are already contract have already been awarded. Rest of them are in various phases of the progress, and this is going to fundamentally change the distribution companies or the entire power sector. We will have time-stamped digital data of power consumption every 15 minutes, and that is going to be the building block of digitalization of the Indian power system. So one of the early adopters of smart metering was Indore, and I have the honor of inviting Mr. Puneet Dubey, who was the just demitted office as last month, demitted office as director commercial in distribution company in Indore, and they were one of the pioneers of adopting smart meters several years ago. Sir, over to you. Yeah, you have a presentation or?
Good morning, respected dignitaries and the distinguished guests. This time I'm going to present on the West Discom's experiences in the smart metering. We had started, this is first glimpses of my Discom. It caters about 60 lakh consumers, covers 15 districts in the western part of the MP. We had about 7.54 lakh smart meters deployed so far. In the high value consumers, which are gradually shifting to smart meters, about 39,000 AMR meters are there. And in the balance 38 lakh consumers, we are going for the photometer reading. Now, we started smart metering in 2017. The question comes, what was the need of doing that thing? The major reason was, as with most of the discoms of the country, we are plagued with the problems of poor billing efficiency, poor collection efficiency, FT areas, lack of efficient mannerism, efficient technology for disconnections, errors in manual reading, and lots of bill-related complaint. To overcome these things, we started analyzing the requirements of the smart metering, and then we went for a smart metering in 2017. It was a RF-based solution, and we started adopting it in Indore city, which is one of the cleanest city. I will say it is the cleanest city of India. We covered about 44 feeders which were having high losses. And the features of the smart meters you already know. I will not go into the details of that thing. So far, we had awarded about 16.65 lakh smart meters, which covers consumer meters, DT meters, and feeder meters. And these have been covered in 5 different AMISP projects. Further, the balance 28.09 lakh consumers are to be awarded for smart meters in RDSS phase 2. Now, having installed these smart meters, we come with a huge volume of data with the smart metering system. The different type of data available are instantaneous data, which are the readings in every 15 minutes of the fundamental voltage, current, power factor, cumulative kWh, etc. The load survey data, which again comes at the interval of the 15 minutes. Daily load profile once in a day at 00 hours. Billing data once in a month. And the event data as far as at any time the temper occurs. A single meter throws about 134 kb of data in a day, and if you convert it to the scale of 7.5 lakh meters, the data is of the size of about 3000 GB. It's a voluminous data, and compared it and calculated it in case of the large scale deployment in the country. What are we going to do with this data? One purpose is simply to do the billing and forget about it and dump this data. The second thing is to do the meaningful analysis with it in getting our planning, DTR conditions, identifying the thefts, tempers, pilferages, etc. We are doing three type of analysis in this thing. One is the consumption based analysis, second is the event based analysis, and third is the data based analysis. We had deployed about 63 different type of reports and have put up an elaborate marking system for each of the temper or each of the event, and then we plot them and consumer wise and assign each consumer a mark for that thing. The consumer having the highest marks is considered to be the most critical, and the consumers which are having normal marks are critical, and like so on and so forth. The most critical events have been handed over to our vigilance officers. The critical events have been handed over to our metering people, and the normal events are being dealt by the zonal officers. Our action taken report is being populated, and based on these action taken reports, the field officers do their checking and put their remarks in that action taken report. We had identified about several revenue leakage, just like meter tampering, remote circuit in the meter bypass, direct theft, temper of current without voltage in three-phase, mismatch in phase and neutral current in single phase consumers, tariff misuse, consumer lying disconnected for more than 2-3 months and still surviving without electricity, violation of sanction load, power factor penalty, and sudden drop in the consumption. We had developed a theft detection board in our laboratory, and with the help of that theft detection board, we stimulate different type of tempers and study the effect of these tempers in the meters. And this theft detection board is also used for training our field staff to check a particular type of temper. I will show you certain temper cases which we had identified. You can see the most common temper which we have identified is shorting of phase and incoming and outgoing, shorting of the neutral terminal, then bypassing of the service cable. Recently, we had also discovered one temper where the circuitry has been tempered, the cover open circuitry has been tempered, and a remote device has been inserted inside the meter. With the help of that remote devices, the culprit was doing and controlling the current circuit as well as the voltage circuit and was tempering the voltages. With these things and with these analysis, I would like to now come over to the project benefits. Before that thing, I would like to have a challenge to the field, to the industry peoples. Our data which we are getting, we need a dedicated and a effective AI/ML intervention for proper analysis of these data so that we can do meaningful analysis and can arrive at a fruitful result and can fully utilize the smart meters. The project benefits are our average monthly consumption units have increased by about 13.63%. Our monthly bill per consumer has increased by 250 rupees. Based on the temper analysis, we had identified about 18,000 cases of aberrations and we had billed an additional 21.96 crore rupees. About 96.28 megawatt load has been increased due to violation of sanction load, which has resulted into a recurring revenue of 81.78 lakhs rupees. We had recovered about 8 crore rupees of power factor MD greater than sanctioned load penalties. As far as the power factor penalty is concerned, we had recovered about 7 crores from industrial and IP consumers. Now, as far as the consumer perspective is concerned, our bill related complaints have been considerably reduced. And here again comes another challenge to us with 100% deployment of smart meters. The problem would be faced by the distribution utilities in properly doing the connection as well disconnection as well as the reconnection. Here again an intervention from the industry is required to have a local level intervention to satisfy the consumer. As soon as he recharge his thing, his connection should be connected. These are the several benefits, and the government is also being benefited with the smart meters, our improvement in the financial health of the discom, and addressing our subsidy to the genuine consumers, because in Madhya Pradesh there is a subsidy of about 1 rupee per unit for up to 100 units consumers, and now with the help of the subsidy, the smart meters, the subsidy can be addressed to the genuine consumers. Thank you very much.
Indoor experience. Continuing on the same thread of smart metering, I would now request Anil Raval, Managing Director of IntelliSmart, which is a joint venture of National Infrastructure Investment Fund and Energy Efficiency Services Limited. And they are the pioneers of smart metering in India. As we speak, 12 million smart meters are installed and functioning today, of which 8 million are installed by IntelliSmart. Over to you, sir.
Yep. So thank you, Mr. Reggie. Small correction. So it's not us, it's counting he's making with my parent company, which is ESL. So as IntelliSmart, I think if something is to be credited, that's about we doing first RDSS project in the country ahead of schedule in Assam, which was about 6.2 lakh meters, and completing first gas smart metering project in the country in the OPEX mode, which has just recently been completed. That also ahead of schedule. So good morning. First of all, thanks a lot for calling me. And I have a small presentation which is trying to cover on the criticality of the program and the way where we stand in the journey, and from here where we can go. So I'll try and cover the things quickly. First of all, there's no doubt about the fact that this is a once in lifetime opportunity for all of us in terms of uh, improving the distribution sector. Just a minute. Yeah, because we understand as power sector professionals that the losses have been too high, and normally it has been considered that this is a loss reduction program. Obviously, that's the key use case of the program. This is one of the more than that, it's one of the largest digitalization program in the world, touching more than 1 billion people at household level. I don't think such large program has ever been implemented across the globe at this scale. It will have really far-reaching impacts as we are talking about the T&D losses, improving the efficiencies. Would say about estimate is about US dollar 1.34 trillion of losses in next 10 years, which is about 1/3 of India's GDP, let me tell you, as on date. Would have potential to generate about 250 million jobs in skilled and semi-skilled categories, and would trigger an investment cycle of US dollar 38.5 billion, which is again a huge thing. Revitalize Make in India, which is it already doing and has really done well so far itself. And it will certainly rewrite the script of the consumer voice in the grid. That's the way we see this program on the importance side. More than T&D losses, which we already always talk about, I would like your attention to be to other things which are, I think, more critical. T&D loss is the base use case of the program. Beyond that, if you want to reach 500 gigawatt renewable capacity, you need grid resilience, which can't come from the supply side. It will more come from the demand side, and demand side will be managed by the smart meters. Grid flexibility due to variability, that would be again managed by right kind of data and control and the consumer pattern at the ground level. Demand side management, I already spoken. Rooftop solar. We are talking about the large scale rooftop solar in the country. We have not done much as country on the rooftop so far, but now is the biggest opportunity because there are more than 2 crore applications, as I understand today, which have come for the solar rooftop program, which is being launched in the country. This rooftop solar just can't be done without smart metering put on the ground. That's a prerequisite. And then EV program, EVs are coming thick and fast. They are coming irrespective of the drive from the government, they would come, and then it can't be done at the ground level beyond the distribution transformers if there is no resilience in the grid. And that can be best managed by knowing the requirement of the grid below distribution transformer. And that can only come when you have the real-time data, and that can come through smart metering. So that's why I say EV program would depend a lot on the success of the smart metering. Now, before I go to this, that what all digitally can be done, I want your attention. Where do we stand today? So about 14 crore smart meter orders have been awarded so far in the country. About of whatever 25 million or 250 million, we talk about 25 crore households. About 11 crore meters have been awarded now, where more than 7 months have passed. But this itself is a huge success of the program, I would say. After all, there is a standard bidding document which is really, really well built. It has really been successful. It has been adopted by the utilities. It has taken us long distance in awarding the projects, and they have picked the ground. It's no less than a dream coming true. People were talking about a few months, a year back, that how this large program can be handled and done in so fast. I think we are seeing the success of at least rollout of the program in big way in the country. But let's just step back and see that what more has to be improved. I'll take off from exactly the point 11 crore, which is about more than 7 months awarded. Out of that, about 9 crore order book is there where system acceptance testing is yet to be done. That's a bit of concern on the program. And about 5 million smart meters out of the RDSS program, I'm saying, have already been rolled out. So it's obviously slower than expected. That's the reality part of the program. So while the program has been structured very well, kept the ground very well, awarding has been really great, we may have to actually look at what is impacting and how to pace up the program. Certainly, the pace of rolling out on ground is less than desired. And in that context, I really value this conference where we are deliberating on this topic because if not now, it will be a bit too late in the sense that these projects are 27 months implementation period projects. And if 9 crore meters have passed 7 months and have not got system acceptance testing, then it's a bit of concern. Roadblocks are normal in the large scale mission projects, but then it's also very important that they review the trajectory and correct it so that we can reach the goal in time. Having completed our first project ahead of schedule in Assam, I have some amount of sensibility on how to and where to scale up. And I would like to share thoughts here that that was a small project, but now we are onto large projects. And what we should do, 3, 4 things, which would really pace up the program to the desired level. I would think first we should do in this country is that have a large scale nationwide consumer awareness campaign. This program is still being thought by consumers as being pushed from somewhere. It lacks pull. The technologies and evolutions which lack pull are difficult to go down the brains and psyche of the masses. Particularly when the program is such which is asking them to pay upfront, then there are multiple stoppages coming in the program. Sometimes we say that you do first the DT metering, sometimes you say do feeder metering. So that's actually causing lots of distress in the viability of the program. Then there's a serious skill gap. There's a serious skill gap on the digital side of the program. So these are few things which need to be addressed currently. So to scale up the program on the ground. Now coming to the next topic on the what digitally we can do about the program, and then I would say that this program is extremely effective in terms of we know the remote operations, we know TND part of the program use cases on account of remote connect disconnect, which actually this program enables. Then time of use, time of day has still not been fully implemented on ground in our country, which can certainly be done from now on. Let's enable the regulatory framework around that so that time of use and time of day is implemented properly. Uh, we know that what kind of data you can get from these programs is really immense in terms of accurate and timely meter reading for loss reduction and interventions. That's extremely another part of the program which will lead to smart grid in the country. A smart grid is a grid which actually responds instantaneously to the demand and supply, and that is must for a resilient grid and a grid which actually respond to the future needs of net zero and renewable integration. Early detection and response to the load increase, that's a demand response that also can be achieved through smart metering. Then resource optimization, I got the slip, so I'll take just 2 more minutes. Resource optimization and plugging of revenue leakages. I'll just take you to the next slide where we have done one AI ML pilot program on smart metering in Haryana, and that's about this. There are 4 use cases we tried, 5 use cases we tried to do in Haryana. One was the commercial loss reduction, theft reduction through payment default reduction, and demand forecasting, consumer linked demand management, consumer home solutions and value added services, and network management and technical loss reduction. So I'll just now take you to the next slide where we actually did this in Haryana and see what are the results we have achieved. Out of these 5 use cases, we tried few on the ground and we took the baseline data. We agreed with Discom and agreed on the baseline data and then implemented the program on certain feeders and saw the result. What it brought out is on theft detection. There was 120 baseline cases when we started and we could detect 252. So we could double up the theft detection through AML application of the data. Billing ratio, it was 1.068. 14,047 consumer with total consumption of certain units were not billed. It was detected. Then contracted demand. So we could see that 27.89% of total consumer exceeded sanctioned demand. That's again could be detected through the data. Then high bill generation analysis carried out, which was 7,225 consumer defaulted due to high bill. This again could come through the data through the AI and data analysis. And complaint defaults. About 5,660 consumers who had raised complaints to Discom have defaulted on their payments. That's complaint management. These were the few use cases which we tried to do through AIML and the data analytics of the program and could give really significant impact analysis to the Haryana Discom. So that's all about my presentation. So generally, I think it's a high time that we pick up the pace, and because there is no U-turn on this program, we have to take it through the whole distance. Yeah, thank you.
For that last slide, which is shown about the AI/ML application, which IntelliSmart done, they were given ISGAN Award of Excellence in 2022. Congratulations and a big round of applause to IntelliSmart for that. Traditionally, power sector globally was very conservative in adopting new technologies or trying new technologies. That is another mental barrier which has broken in last 2 decades. Every new technology which you can think about today, including generative AI, are today being applied in power sector, including in India. We work very closely with a set of people who work on colonizing the moon and the Mars, which is on new energy systems and architecture. So this is from US University of Southern California. So many of the things which they are developing it may be done in Mars or Moon, maybe 100 years down the line or 200 years down the line, we don't know. But many of those technologies are today relevant in on the ground on the power sector. So hence so what I'm going to do here is about, this is more of a reference slide deck. There are many slides, but I take only less than 10 minutes to go through it. But India Smart Grid Forum was set up by Ministry of Power in 2011. Our main mandate is assisting the utilities and uh, policymakers in selection of technology, standard development, etc. We have richly contributed in the last 10 years in several policies and programs for grid modernization and energy transition, including electric mobility. Many white papers and research reports have been published, which has influenced the policy making. So we talk about first about digital transformation. You heard about the 250 million smart meters being leveraged for digitalization of the Indian power sector. Digital twin is a new concept which is not new. It's about 2 decades, but in power sector it is new. And you can have a virtual plant along with a physical plant. If you build a virtual plant before the physical plant, you can optimize your design and your material in constructing that. And after commissioning of the physical plant, you can integrate the physical plant with the virtual plant. All the data will come. We could do a lot of what if scenarios and simulation, taking it to a predictive maintenance regime. So there are many benefits of that. I won't go through all that. This all, you people could read it. The deck will be available. You heard about AI, ML, and advanced analytics. And last 10 years, the development of AI been very, very fast. Every day, things. That's the confluence of several technologies and the computing power and communication. All together, this confluence of several technologies, particularly the cloud. You don't need to own anything. You can rent any computing power today on a monthly basis. So entire value chain of the power sector, from generation to customer operations, there are several use cases of AIML. In customer operations, there are several dozens of use cases. In grid operation, there are 23 use cases. In advanced metering, there are 33 use cases. And coming to machine learning itself, you will be hearing all this supervised learning, unsupervised learning, reinforcement learning. What are the main techniques which are used and where we are applying it? So the techniques, the potential customer problems that can solve, data input formats and applications of each one of these are given in the backup slides. There are 16 or 17 different use cases of AIML in the power sector applications. We have training programs also on that. The popular programming languages used for AIML are Python, Java, R, etc. And there are libraries, very popular libraries, which are used for training the models. So here I just talk about one or two of the applications for AI, for RE integration, revenue maximization, loss reduction, EV integration, SCADA. Each one of this one, there are separate slides in the backup slides. You could go through it. Advanced analytics, this is again into 3 different categories. Descriptive analysis, which will condense data into smaller useful bits. And in predictive analytics, you could do what if scenarios, forecast what might happen in future, and what all will happen, why this will happen, identify correlated data, etc. And last one is about optimization, stochastic optimization, that is prescriptive analytics. So all these are made possible by AI and ML algorithms. So I just mentioned about the AI and generative AI. Generative AI is something which can develop new content. The traditional AI will work with algorithms on the existing data. Nothing new can be made by that. The key difference between the two are here, and more slides are there in the backup slides. So immersive technologies, AR, VR, mixed reality, extended reality, and metaverse are new concepts which are being used extensively for training and several applications in power sector globally. And Indian utilities are also, I'm very happy that they are using many of these technologies. uh, Augmented reality and virtual reality. There's something called assisted reality. This is a slide which you'll see a technician going in a remote place, looking at opening a transformer or any equipment or a turbine. If he has connectivity, whatever he is seeing in front of him will be seen by an expert sitting any part of the world, and he can tell him what to do, how to do. And same device, assisted reality device, can open even a manual, operate in manual, and he could read. So these are all things which we couldn't think of even 5 years ago, and those are all became reality and affordable today. That metaverse is a virtual area where you could make your own avatar and be part of the immersive experience. The industrial metaverse is expanding fast. Recently, in one of the Ministry of Education grant, they had given a challenge, and along with IIT Hyderabad, we have done a one lab and one building of IIT Hyderabad. We created a digital twin in a metaverse, and now we are going to do that along with another team of people. We have applied for a grant for doing a substation, a digital twin of a substation in a metaverse. So this is a very interesting area. Traditionally, you could rooftop which you have today, about 800,000 rooftops are connected to the distribution grid today, and you can sell, and all the states for that matter have net metering policies barring one or two in the northeast, and you can sell your surplus generation only back to the grid, whereas many times it is not very attractive or for the prosumers. So we tried some pilot projects in India doing that on peer-to-peer trading. So blockchain technology, we all know about. I won't get into the details of that. And there are several, more than 2 dozen use cases of blockchain technology in the power sector, including one of the main area is the renewable energy certificates and the P2P energy trading. So first pilot we had done in 2020 in UP. Second one we have done in Delhi with Tata Power, about 117 participants we had. In UP, because of COVID, we had only 12 participants. And in Calcutta in 2022, we did with more than 1,000 participants. I'm very happy to say that we are first country in the world where regulations issued by regulator that P2P trading is legally possible. And the UP regulations came in 2023, and in Delhi, regulations were issued by DERC in June 2024, and Karnataka came out with that in August 2024. So we are working with few other states. I believe by end of this financial year, there will be half of India P2P trading will be officially possible. This is the beginning of the energy internet. So this is we work with a organization called FIDE. So FIDE.org, this is promoted by Mr. Nandan Nilekani and team. So financial area, they have been working on it. ONDC platform is part of, it is built by FIDE. Now we are trying to take that same experience into the P2P trading of electricity. So here, above the blockchain layer, there will be a digital layer where prosumers and consumers can discover, enter into smart contract and facilitate that trade, and the money transaction will automatically happen. The reason for this is because UP, as I said, the regulations were issued in 2023 April, but the UPPCL was not very happy about fiddling with their billing system. They have about 30 million or 3 crore customers whose billing system with great difficulty it is working fine. For this P2P transaction, if the billing system need to be changed, that was not the best of scenario. So they said that you find out some other way how this P2P trading can be settled on a different platform. So with this we came out with this will be again uh, piloted in UP next month. I won't get into the details of it. Jain Saab in the beginning context setting, he talked about V2G, vehicle to grid. India being in the forefront of vehicle electric mobility, and we are advocating for V2G. We are going to do a pilot project very soon. It may be commissioned most probably in October or November. We wanted to do it in June, but then some experts from outside, our project partners are from University of Delaware, USA, and June was not conducive at 52 degrees centigrade in Delhi. We didn't want them to come and stay here. So next month they will be here and will be doing three private utilities in Delhi, BRPL, BYPL, and TPDDL, all three of them. And Kerala is very keen to participate with Jyotilal sir's leadership. They've been wanted to be part of this project. So one vehicle will be in Trivandrum and three vehicles will be here. This is AC V2G, where you go to your office, you plug your car into a bidirectional charger, and you can program it when the price on the grid. And as you know, there is already Government of India policy that high solar hours, the prices will be less. 20% discount can be given during high solar hours once smart metering is completed. So you can program your car when the price on the grid is less than 4 rupees charge. When the price is more than 7 rupees, sell it back to the grid. Keep enough to go home for 50 kilometer. So these things will be, and Tata Motors is also working closely with us. I believe that Tata Nexon is the vehicle which you have taken for this trial in Delhi. And one demonstration site of BRPL is actually inside Delhi Electricity Regulatory Commission. So it's going to happen right in front of the policymakers. And like in the P2P blockchain regulations, India will be one of the first country to have regulations incentivizing EV owners to participate in V2G. We hope to have that very soon. So another thing which we are trying to do along with that is charging of EV with green electricity. Today, you take your car to a EV public charging station, you don't have an option. Grid power, whatever, 20 rupees, 30 rupees, whatever, you just charge it. So suppose your app, EV charging app gives you an option, charge with regular grid power or green power. And if you press green power, end of the charging session, we will get a crypto token, an NFT as 20 units of electricity you have put in your car. That certificate of origin of the green energy can be monetized in carbon market and in emission reduction obligations, which many fleet operators have it. So the smart meters of the charging station and the smart meter from the origin of the green energy, a solar farm or a wind farm, that will be connected to a blockchain platform that is going to create this token, a certificate of origin. And digital tools for efficient management of distributed renewable energy. As I said, we have about 800,000 solar rooftops, and the new program, PM Surya Yojana, Bijli Muft Yojana, is going to add another 10 million or 1 crore solar rooftops. This 800,000 or 8 lakh solar rooftops, which is about 12 or 13 gigawatt of energy, capacity, which is connected to the distribution grid. Every day it produces more than 40 gigawatt hour of electricity, but no visibility. Where is it? The grid operators, the SLDCs, RLDCs, they don't know. So in a daily scheduling and dispatching operation, this 40 gigawatt hour energy is not considered. So how can it be? So we got a small grant to make a national rooftop registry. Several countries, Australia being the pioneers in making a rooftop registry. So we are going to make the architecture of the registry. We have adopted such a way that all DER in future can come here. So the registry is live, indiader.in. As part of the program, the first grant which we have, we are entering the historic data from two distribution companies, Indore and uh, Rajkot. So these two put together has almost 4 lakhs of rooftop out of the 8 lakhs. And this we will be unveiling this next month, 14th of November, the registry. Rest of them, some minor changes will be made so that from the national portal for the PM Surya Yojana, the data can flow into this registry. And at a later date, we are planning to integrate the real-time generation data with this. How it will happen? Smart inverters and grid forming inverters. So smart inverters conforming to IEEE 1547 is already adopted by BIS. Last 2 years we've been working on this, and it's only to be published. The publishing will happen end of this month or next month. And already the same ETD 46 committee is working on grid forming inverter standards, which is IEEE 2800. So biggest challenge today we have, as I said, the 800,000 solar rooftops which are connected with the inverter, the dump inverter which are there. All of them have some applications. Many of those who have rooftop prosumers, you watch your daily generation on a mobile app. All that app, you are getting it from the data from a Chinese server. From your inverter, it is going to some server in China and then it is coming down. So we've been arguing with or advocating with the Ministry of Power, CEA, that we have to have a national app. All new inverter which will be sold will have a national app. Same with the EV charging applications. There are a lot of backup slides. Please go through it, 60, 70 of them. We do two events, annual events. One of them is we've been doing since 2015. It's called India Smart Utility Week. Next edition is on 18 to 22 March in Delhi. Distribution utility meet we've been doing since 2018. This is in partnership with the different discoms or the energy departments in different states. Last year it was with KSCB and Kerala government in Kochi. This year it is with the UPPCL in Lucknow on 14th and 15th of November. And we invite all of you to please, all utilities are free to participate, and it will be followed by a special visit to Ram Mandir on 16th of November. Thank you very much. I leave it here. Let me change the presentation, please. So I mentioned in the beginning about 24/7 electricity supply, and this will not happen anytime soon unless we adopt hotline maintenance. Even for changing a small insulator or a wire joint or a cross arm, in distribution we are taking our linemen go and take shutdown and for hours and they do it. When this happens, a shutdown happens, those who have DG set, they run their DG set, which is not, we will never reach a net zero with that practice. In hotline maintenance is something which is being done by power sector utilities around the world for more than 50, 60 years. In fact, the next speaker from Altec is going to be a 100-year-old company. They make specialist tools and insulated platform for hotline maintenance. In India, also our transmission companies, Power Grid and several other transcos, they do hotline maintenance for at least 25, 30 years. In 400 kV, 765 kV, they are doing it. But in 230 volt, 400 volt, we are not able to do that. ISG have been working with different stakeholders. We got some equipment and done a demonstration in Bangalore 2 years ago. And I'm very happy that, as in many other areas, Tata Power Delhi Distribution has taken the first step of buying a set of equipment which may be available by end of this year or before March. So thank you very much. And let me invite Puneet from Altec, which is the world leader and a pioneer in hotline maintenance. Thank you.
Good morning, everybody. Uh, I'm here to talk about hotline maintenance, but before that, let's come at understanding of what we mean by smart distribution. According to me, it's more of intelligent things coming into the management rather than the traditional approach. This is what the broader thing about a smart distribution system would be. The two drivers, which are the levers, which would develop this sector would be digital communication and automation. I think that's what is going to evolve over a period of time. It will continue. So these would be the levers which will move the things forward on this. But we are talking about maintenance. Let's look at how the things would be. I think nobody is going to allow power cuts, not even for a very important maintenance activity. That would be the future. Asset upgradation, going underground, all are good. They will help supply to some extent, but ultimately the maintenance has to be done for whatever system you adopt. And even if you adopt automation, auto reclosures, many other things, but ultimately, if there is a fault in the system, somebody has to go there and set it right. That's the physical part of it. So you need maintenance. Okay. The other thing which probably has come in is that there would be a very high component of renewable energy. Uh, with that, the challenge comes in that you don't have, leeway to shut them out when it is, giving you the power. Even in construction, we have seen people are not giving shutdowns. So shutdown is out of the window. What would happen to maintenance is that the concept from shutdown or breakdown maintenance, it will move to preventive, different steps of preventive, time based, condition based, predictive, proactive. The ultimate would be the proactive one. This is what we do. In the shutdown, we engage all the resources at one point, get it right as quickly as possible. What we want is a proactive approach where there's no time pressure on maintenance. Just for the understanding of all the people, there are four types of live line maintenance. One specific to distribution is gloving and barrier, where the gloves and barriers are the primary insulator for the worker, and then you have the equipment, which is an insulated platform. The other method is at a distance, you would the hot stick, and then there's a tool at the end. You set it right. The next one is the contact work, which probably the transmission utilities use. They go equipotential and then work with their bare ends. That is why it is called bare end. The other part is, sometimes temporarily de-energizing, we still put it in a live line maintenance because there is effect of induction. So that hazard we have to take care of. So that's included in live line working. What would be the cost? That's one of the important part. You would need a specialized equipment, you would need tools, you would need, workers with extensive training. You have to have a risk and safety measure, stringent protocol for that. The labor cost definitely is going to go up because you have a trained manpower who may demand more. You cannot pay him as equal to other ones. So the cost of the labor is going to go up. I bring forward a small understanding, that what it will cost to bring an insulated aerial work platform. That's IAWP. The equipment itself would cost about 1.1 crore. The tools about 0.28 crores. Training of 4 crew members. I'm talking about per equipment basis. You need a crew of 4 people per equipment. It's about zero point 0.1 crore. Additional cost of manpower in the sense that you have to pay more to them. So I have already included that. This comes to about 1.52 crores per equipment. We will see how these economics work when we compare it with the losses which we would prevent actually. A city like Delhi would consume at the minimum at phase one level of things about 10 number of these platforms or these kits. And the payback period is just 2.5 years only. And I'm saying phase one because as a country, we have not been doing live line maintenance in distribution sector. So there is a learning curve which would happen. And that is why I have said a phase one. If I look at, there was in financial year 24, 18.8 million units were scheduled maintenance losses or revenue losses on that. And there was 18 million unit unscheduled. So I say about 90% of the scheduled maintenance because you know what you're going to do, so you will do that, and because of that your maintenance would be good, and probably you can save on those unscheduled losses, in the sense the system shutdowns fault base would be less. So in all you can cover it in say 2.5 years. Going through the benefits, one is that you are getting a reduced downtime. uh, it minimizes outages. Barely in one or two cases where probably you have to change the pole itself, it may take some kind of a outage, but otherwise you can do without affecting any service. The revenue is going to go up. You can cater to your commercial and industrial customers better. The quality of maintenance also would go better. There is no time constraint to do the maintenance. Power is on, there's nothing which is getting affected. Whatever maintenance you would do would be of a good quality. You're not in a hurry to come down so that the power can be put on. Power is already on. This all things would improve the reliability in the sector. uh, you know uh, Regularly you are going to be doing the maintenance when required, so the reliability is definitely going to go up. And there is something which I have not mentioned here, is safety. you know it is much safer than shutdown maintenance, because the operator or the person who's going near the power line, he is aware that it is running at this voltage, so he would take all the precaution required, and that is why it is more safer. you know Time taken to do the activities itself would reduce to a great extent, because the time would be less. You have a very mechanized thing, the platforms to go up and work with. We as a company can offer, along with our distributor, which is Taurus Powertronics, give you all the things available: tools, trucks, and training. This is what we are going to offer for the Indian market, because I think training would also be a very important component in this part. What challenges I feel would come across would be the skilling of manpower. It is very important that we skill our manpower in a way that we reduce everything on the accident part. The other challenge which would come is way of work. मैं तो ऐसा ही करता हूँ. That is a challenge. So that challenge also has to be taken. There is a development of SOP, which have to be created, but it's going to only happen when we move and do the maintenances and learn from there and put those SOPs in place. The ecosystem also has to come up. The ecosystem of the equipment, the tackles, the training, and many other things associated with this, and the guidelines also for live line working. The way forward would be, you know, it is very important that we should move away from fault-based maintenance to a predictive model, and this is the minimum to get the benefit out of the system. Okay, the biggest challenge would be, as I already told, would be manpower, not only on the skill but on the attitude also. So you have to take care while you are training. The attitude also has to be set right. The guidelines to develop, probably for the timing we can adopt whatever is available in the system worldwide. This practice is as old as about 100 years. You know And as a process, we can bring a phase one that we do not do all the activities. Let's chalk out maybe 10, 15 activities which we are going to do on a live line, and probably when the competency goes up, we bring the next level of live line working. So it's a learning curve. Every utilities would go along this way. But what I can tell you is almost all the work which a distribution utility would like to do can be adopted for live line working. It's insulator change out, repairing a conductor, changing jumpers, everything. Even there are many videos on YouTube which is changing of poles in live condition. So you can go and see. It'll be wonderful. Thank you very much.
Thank you. So there is a hotline training center under NPTI in Bangalore, and a lot of people from outside India come get trained. Our Transco send people to get trained. Early this year, Ministry of Power has returned to all the energy secretaries all across the country to depute their DISCOM personnel for hotline training in HLTC Bangalore. So we call upon DISCOM officials to please take that on priority. So nothing smart can be done without reliable communication. And next session we will focus on more on the digital communication technologies for supporting the fast growth of RE, EV, and the entire grid modernization. So I have the pleasure of inviting Amarjit Kumar, who is the India representative of Bison Alliance. So we are running a little late. I given 10 minutes now, 8 minutes.
Um, I'll start with thanking REC to host this and congratulate REC to complete 50 years, successfully running the country in a future direction, I would say. So, since we have very less time, I'll start with uh, basically the importance of communication technologies. What are the challenges, what we see in terms of when we are basically talking about the communication technologies. We will be talking about what we have today in terms of communication technology, what we are using and where we are lacking. And also, I'll touch upon the global trend and the future directions, what we see globally, how the communication technologies are evolving and how things are going forward. So, generally, what we see is communication technology is a piece which is providing us a two-way communication, real-time monitoring, and things like that. But to me, the communication technology, I would say, if I look at a human body, the communication technology for me is the nervous system. Now, what does a nervous system does is it delivers what your body sense. It delivers to your brain and vice versa, right? So that's what the communication technology is. Without communication technology, whatever we are talking here, anything we talk, use the word smart, doesn't exist. So that's the importance of the communication technology. Unfortunately, the in communication technology is not being taken that seriously when a overall system is designed and deployed, because there are certain things which we miss out. Uh, we so I will talk more on those, like solutions and requirements. So when we try to work on a solution, we see is we have so many standards. I have tried to capture few of the standards at each layers of the communication technology, and we tend to get carried away with the communication solutions what we have. What we don't, we are not using the based on our requirement. uh, in turn, what we are doing is we are trying to take the solution which is available in the market and try to fit it based on our requirement, whether that is going to solve our problem. Yes, in short time it does solve our problem, but may not be a long term solution. Why? For solution requirements, we need to understand our basic requirements, what exactly for which application we are doing, what is our basic requirement, the kind of latency we are looking, because every application, every requirement have a different use cases or different end-to-end requirements in terms of bandwidth, latency, reliability, security, and many other things. Also, we need to look which kind of communication technology is suitable for our application, because not all communication technologies are same. All are catering to different use cases. There are overlaps in terms of certain use cases, but not all communication technologies is fit for all kind of application. So we need to look from a different perspective when we are talking about a communication technology. We talk a lot about interoperability when we talk about communication technology, but this is something which we when we talk, some people say that no, this is not possible. Some people don't take it in a right direction, right? So interoperability to me is, if you look at the image what I have shown here, at each layer we are using various communication standards, right? Because when you look at a car, right, in a car you have so many things and every component of that car is following certain standards. So similarly in communication technology also we have 7 layers, and each layer have so many different communication technology. When you build the end-to-end communication platform, you are using one of those standards in your solution. Now, the other vendor may not be using one of this in one of the layer same tech standard, and which makes it non-interoperable. So how do we achieve that interoperability? Maybe by defining a system level specification or a standard, which is done today. We have system level standards by IEEE, which is adopted by IS also. So we have done a lot of work there. Interoperability is not only on a specific communication technology, even we need to look much beyond that, that if we have multiple communication technologies being deployed, how do we achieve interoperability at the application layer? How do we make sure that the data coming from cellular technology or RF mesh technology is going to the same server? Now, that is also a challenge which we are trying to handle. There are a lot of work going in the background within CEA also to address those concerns. Um, more and more connectivity we do, more and more new connections we do, more and more challenges also we have to face. And the today's biggest challenge is basically the security. Now, security is something which, again, I would say is not being paid the right attention. I always categorize the communication technologies in two categories. One is your critical infrastructure, communication for critical infrastructure, and communication for non-critical. Now, the moment you say critical infrastructure like smart grid, smart metering, all those applications are basically a critical infrastructure. There, the security has to be on the top, where we see that that is not paid right attention. We are not paying right attention there, and that's where we see a lot of security threats globally, not only in India. It's a global issue. Uh, we need to adhere to the highest level of security standards, and some people I see making comments that if it is not standard, if it's proprietary, people can hack it, cannot hack it because they don't know how the security is implemented. But that's a wrong notion, because if I am a vendor which is providing your proprietary security, if I have a 5 people team, only 5 people is working on that technology. The moment someone hacks in, only 5 people sitting there to fix that. Whereas the standard works other way. Standard is open. They uh, it is open for people to hack in, and there are people sitting behind who is improving that standard day in day out to make sure that various kinds of security challenges can be addressed. And that's how the standard works. So a standard is a living document where it gets upgraded as and when there is a loophole found. So it is very important to basically stick to a standard based security. Also, if you look at the security, I always see there are two components. One is how good the data is encrypted, but then there are other things also like authorization, how the security keys are being handled. Those are much more important than how secure your uh, how much encryption is basically applied. Because the moment key is out, your encryption, however it is of no use. So that's the second part which also needs the right attention, which I see missing in today's deployments there. The other thing which I see is today what we are seeing is all the rollouts are basically very siloed. If we are doing a deployment for smart metering, the only application we are keeping in mind is smart metering. Tomorrow we are talking about in previous talks we talked about V2G, V2V. We talked about solar rooftops. We talked about charging stations. Now all these has to get interconnected. Whether the communication technologies what we are deploying is capable of integrating all those. we are not thinking on those directions. So we need to start thinking now, because when those application comes to you, it will be too late. You would have already deployed, and you cannot have multiple communication technologies deployed for various applications. Apart from electric grid and related applications, there are other also smart city applications which needs to be get a better ROI of the investment. So those things are also needs to be looked at. The standards what we have today, primarily we are using cellular and RF mesh. Cellular we are using 4G, NB-IoT, and going forward 5G is also being dealt with for some of the applications. RF mesh, where we have two standards, basically one a standard IEEE 2857, which is adopted as IS 18010-5-1. This again gives you a end-to-end complete stack interoperability from physical layer to till the transport layer. And there are so many varieties of other RF mesh are available, which is making a lot of issues in the field when it comes to when we talk about the interoperability and scaling, uh, integrating multiple application. Because when it is proprietary, you are stuck to the vendor, and if the vendor is supporting only one application, you cannot integrate it with the other applications, so you are stuck there. So those are the standards which is being used today. I'll talk about the global trend and hybrid technologies in another minute. That's what I have been given. So what we see is, we in India also we have tried PLC, right? And PLC did not work on a large scale because of various reasons, the noise and the quality of cabling and other things. But then RF also have a problem where we are not able to get the signals, whether it is 4G, 5G, cellular, RF mesh, it doesn't matter. Any RF. If you want to get a signal from minus to basement, you cannot get out the signal. So what we are deliberating in IEEE, in global other forums, is that can we have a hybrid network? So today we have, for internet, we use Ethernet and Wi-Fi. The data comes from on Ethernet and data goes over Wi-Fi and vice versa. Can we do the same thing with PLC and RF? So wherever the signal cannot go, I can use PLC and then throw it out on RF, and then vice versa, to get the best out of both of the technology and create a new technology, a hybrid technology, which solves a lot of these kind of a problem. So those are some of the deliberations going globally, which we are trying to do in IEEE also. Um, Other global trend what we see is we are trying to get the network, a network on which we can have multiple applications. If we are doing one network for smart metering, can I use the same network for street light also, distribution automation also? So those kind of use cases and applications are being deliberated. So that's all for today. I'll be around. If we have any questions, I can definitely help. Thank you.
Yeah, in fact, India was one of the first countries that adopted IPv6 in way back in 2015. So next, I mentioned about smart inverter in my presentation, so I will request Mr. Ravindra Desai to talk about it more from IEEE.
Anyone anyone is running this, or I have to? Yeah, okay. Yeah, thank you, Amarjit. You spoke a little on standards. Yeah, standards are important for any system. And with advancement of technology, I think these are more and more critical. Uh, uh, in the paucity of time, I will try to run away. I will try to run the presentation fast. Okay. So why standards matter in smart distribution system? One is interoperability, cyber protocols, operation safety, data accuracy, uh, grid integration, scalability, okay, and regulatory compliance. Okay. Need for smart inverters. So with target of almost 500 gigawatt by 2030, I think integration of DER with power system or grid are becoming more and more important. So the smart inverters, okay. So these are some of the are not new. Some of the features of smart inverters: grid stability, advanced right-through capabilities, which are not with the standalone inverters, managing bidirectional power flow, as most of the speakers spoke, anti-aliasing protection, remote monitoring, high renewable integration, grid code compliance, microgrid. In conclusion, I will say that smart inverters are essential for the integrating renewables, or what we call DER, distributed energy resources, with the grid, and they offer a lot of advantages. What you have seen, to manage the voltage, frequency, power quality, bidirectional power flow, which are critical for maintaining grid stability and reliability. Okay. Yeah. So there are few global standards. One of them is IEEE 1547. This is by IEEE, and this is adopted. This is a global standard. This is adopted by many countries, like Israel, Indonesia, Malaysia, Thailand, Canada, Vietnam, Philippines, Ghana, lot of countries, and these are successfully in operation there. In fact, in US Energy Act, Section 1524 amended this for integration of DER with the electric power system. So there are good features in this, like enhanced grid stability and reliability, that it supports voltage regulation, voltage and frequency regulation. It has right-through capabilities. It has the scalability to penetrate more DERs into the grid, improved power quality, support for microgrid and resilience, uh, control and monitoring or better grid operation, economic and environmental benefits, consistency and simplification, enhance safety for utility workers and the public, and future proofing of grid. So this is already adopted by BIS. In fact, this is a dedicated series, 1547, and the latest is 1547 dash 2018. 2018 is the year of publication. This is under revision. Maybe by end of next year, the new revision will come. And yeah, I got, yeah. Okay, I'll complete in one minute. So this is a dedicated series, and Amarjit spoke on communication. So there is a dedicated series 1547-3 only on communication. Even there's a standard on impact of DER on the grid. So 1547 is for distribution level up to 35 kV. There is one more standard, which is 2800, 2800 2022. This is adopted by the, or decision is made by the committee which works on this, BIS committee, and this is under review, and even CE is reviewing this. This is for transmission level up to 765 kV. So I'll almost key features are similar to 1547, so I will not spend more time on that. Okay, but in the conclusion, I'll say that 2800 provides a comprehensive framework. Same applies to 1547 too, in integrating transmission level. Only difference is this is voltage level differences there. This is transmission, sub-transmission, and the other one is for distribution. For enhancing grid stability, reliability, resilience, and it also supports large-scale integration. As I said, India is targeting 500 gigawatts by 2030. So this will help in large penetration of DER into the grid. Okay, so it helps in meeting the global sustainable goals. Yeah. So of course, I think this deck will be available to all. So I'm just trying to give some more useful IEEE standards in the space of smart distribution. And for the information of all, I think many of the people may be aware, IEEE's tagline is enhancing technology for humanity. So that is whatever technology is developed that should be useful to the humanity. So I work closely with BIS and CA, and we try to uh, offer this standard free of cost to BIS. So these are some of the standards. If it is useful to India, I think we can adopt that. So standards are really vital for the operation safety and security of smart distribution system. But one more, I think last maybe 10 seconds. But with the advancement of technology, or rather advancement in technology, there should be continuous collaboration between the government, utilities, industry, and standard organization to keep in pace with the technology advancement. That is all is my call for action. Thank you. Thank you
Thank
very
you.
much.
So we have already requested CA to issue rules making it mandatory for smart inverter for all future DER connections, which is under discussion, and also create facilities for testing and certification of smart inverters. So now I have the pleasure of inviting Pramod Mishra from BRPL, who will talk about EV grid integration. And they are, as I said, our partner for V2G demonstration.
Sure, sir. I'll be within 5. Uh, Thank you, CEA. Respected Jain sir, Reggie sir, panelists, seniors in the audience, and fellow practitioners of power sector. This is my proud privilege to be amongst you and giving relating something which I practice. And this presentation is something on the power sector, and I am giving you the DISCOM perspective. So one of the problem, if you see the power sector is facing today, राहुल साहब ऑलरेडी आई थिंक टेकन, वो कहते हैं ना बेड़ा उठा लिया कंधे पे कि इसको सॉल्व कर देंगे. सो स्मार्ट मीटर इज ऑलरेडी on the cart, and what Saraj said ki 14 crores already tendered, and in times to come that will be a reality. Second problem of power sector today is variation in power purchase cost, like दिन में हो, रात में हो, दोपहर, शाम, हर वक्त different है. So how to standardize that, because it are largely depend on the curve, the demand curve. Third thing, I think even if you have capex, सब लोग पैसे की बात करते हैं, but I find as a planner difficult to lay whenever, even if you have money. Like you don't have a space, you don't have right of way to lay additional network. When we talk of 708 gigawatt of peak demand by 2047, so network to evacuate those power from grid and to the customer will be a challenge. I have put a solution as a picture, but I'll not discuss here. I'll discuss sometime maybe during the presentation. So why find that there are two big opportunities in solving these two problems? One of like peakiest of peak demand, and another is right of way constraint. So I find that since EV is now reality, and as per Niti Aayog, about 8 crores of EV will be on the roads by 2030, and that will be about 20 to 25% population of total vehicles on the road. So that gives an opportunity for power sector to harness that, I would say, mobile powerhouse, and V2G can be a potential technology to harness that stored power in those mobile vehicles. So vehicle to grid technology is towards the grid flexibility. This is one of the tool or one of the solution towards grid flexibility, and it allows bidirectional flow of energy. Like हम चार्ज करते हैं कार को, स्टोर्ड रहता है मोस्टली, कार आइडल रखता है. इफ यू सी 24 आवर्स द डे, और जितनी कार आपकी कॉलोनी में होती है आप देखते हो मोस्ट ऑफ द टाइम पार्किंग फुल रहती है कॉलोनी की. इट मीन्स कार जितनी जरूरत है उससे ज्यादा है. So that can be treated as powerhouse, and that can store energy for us, and whenever demand comes, if the technology allows, we can discharge that. If that comes, then this 8 crores of vehicle will be a powerhouse for me. And even if I can harness 10% of that, that will solve my peak demand problem. So if I say Delhi as a use case, I have peak demand, projected peak demand of next year, or say 26 to be 10,000 megawatt. And Delhi is already by that time, say even if I take one case of this electric DTC buses, that will be about 10 to 12,000 electric buses. And that is equivalent to about 3 million units of energy stored at any point in time. And that time, that at the peak time, I'll be requiring 10 million of units. So there is potential of 30%, 3 million unit out of 10 million unit requirement. And even if I can harness 1% of that, that will save my peakiest of peaky demand. So there is potential. I am trying to impress upon that. This vehicle will be also source of power during the cuts at times when it can be converted into vehicle to load. Energy cost arbitrage, because my peak times my cost goes as high as 12 rupees a unit, and the off peak time it is as low as 2 to 3 rupees a unit. So if I can store that energy during the off peak time and discharge during the peak time, that can be one of the use case of vehicle to grid technology. If I can somehow save those peaks, and there is potential to defer my capex and those right away, and the constraint of basically space. What is intended in this study or this demonstration of technology, V2G technology, and then you see that what is the EV ancillary market potential in India. It is also intended to see the energy arbitrage aspect and the impact assessment of this technology on various network and the vehicle. So for this technology, we have three major requirements. One is the vehicle. So to start with, the DISCOMs have provided their vehicle for this pilot, and then bidirectional modular power unit will be the another thing which has to be retrofitted into these vehicles. And then third is the chargers. So these three are the hardware requirements, and if you see the conventional vehicle, it is only the charging option. And with this V2G technology, we have both the charging and discharging option. This is the major difference in the two. For as a software requirement, we will be requiring one battery capacity to be available, and then software to have this instruction to battery to charge and discharge based on the requirement, and mobile application for users to operate. This is essentially the modules which will be requiring two way of charging. And these are the partners who have been in this pilot project. ISG have been pioneering into this pilot. BSS, both the DISCOM, KSAB, Tata Power, Tata Motors, Delaware University, Nuvve for software support, and Wharton Well, SEW, CRIPSI for those mobile application, and our observers are CEA and DARC. As I said, we are installing this in the DRC premises. What is targeted outcome of the project is demonstration that it is possible, and then the policy regulation by the next year for V2G in India, and then different OEMs like Tata Motor is launching vehicle with the BMU fitted into it. Another use case or for on the same concept is like if we can have battery support to our transformer during the peak hours, so you may not need to require to augment those transformers in a space constraint or otherwise, because the peak is only for few hours. For those few hours, if you can provide the customized battery support to the power transformers, distribution transformers, say 50 kilowatt hour, 100 kilowatt hour to the transformer, then you are actually solving the problem of overloading to the transformer. And this solution can also work in tandem, and concept is same in both the case. You charge during the off peak hours, this battery from the transformer, and discharge during the peak hours. And this is the like this can be the benefits you can see if you can charge and discharge the battery as per your needs. So these two things I hope is the one of the solution of biggest respite for the DISCOMs for the challenges it is going to come in by 2047. Thank you, Registrar. Thank you. Sir.
Thank you very much. And invite Shubhadeep for the last presentation. 5 minutes.
Good morning. 5 minutes, says Sumit. Uh, we have four things. I think we have covered quite a bit. Uh, let's go straight to the point. Innovative business cases for smart meters. A lot have been stated, and we have implemented all the business cases that you see on the screen. All implemented in service. This is not what I would like to speak about today. Acha, another thing which is happening now, CEA has come up with the idea of universal HAS and universal NIC. That means your AMI systems will need to be flexible. Your communication technologies, all of them are good, but they will die out in their own times. Electricity will have to be sold before and after that. So therefore, that robust communication overhaul, whatever you say, will be dated. Therefore, we will have to make systems that way. All the technologies that you speak today, which are available in the market, has been implemented in TPDDL. And along with that, one MDM, and now we have two, but we are aiming for one HES as well. Integration of all renewables have been done, grid levels, battery storage, community storage, all has been done. We will give you just two business cases today. Have a look if in case you like it. DT dashboard, smart distribution, DT planning. Data comes in on its own, the planning engine churns itself every day. The only thing that you will have to ensure is that the data is coming in at the right point of time. The job, you call it AI, you call it ML, you call it whatever. We run the business. For us, the job has been done whole soul. Overload planning is done for the next financial year before the Diwali is done. We also have a virtual metering portal for HVDS DT planning where the HVDS DTs are so small you cannot put up DT meters itself. It doesn't make any sense. So with smart meters, the HVDS DT planning portal has been done, with which what we do is all the consumers' data, virtual metering concept. Consumer voltage profile analysis application, etc. The point is very simple. A consumer who adds on to you is ultimately a consumer. He may have solar associated with it, but he's an angry man if in case he doesn't get electricity as per his requirements. So therefore, at that point of time, whatever he is consuming at whatever point of time will need to be addressed in that way. That's the reason why, along with that, when a consumer comes in and you also have a lot of renewables attached to it, your voltage profiling will go up and down. That has to be addressed. India doesn't have OLTCs at DT level, nor is it feasible. So therefore, buying the right DT for places becomes important over here. The results, I don't think I have time to cover, but just one slide. I think you will like this. EV stations across TPDDL. Look at the curve. All 30 days. The EVs are getting charged at night. During the day, it takes a charging period in the afternoons so that the evenings they can run the bus. So peak shaving has happened at what place, if in case you call peak shaving, or rather peak additions? The nighttime loads of all utilities across India is bound to rise. Be prepared for that. Delhi always had a bimodal distribution. Calcutta didn't have it, but Delhi had it. So in this bimodal, the night used to be lesser than the day. It won't stay that way. It won't stay that way. Be prepared for that. This is what we wanted to say. And the peak that is coming is being added in the afternoon will be shaved off. Will be shaved off very smoothly by solar penetration increasing. 7,945 solar connections, and 1952. This is dated. I don't have the latest update, but 7,945 is up to 30th of September. And the total sanctioned load here happens to be 76.43. 51 has been energized, 85 megawatts in solar, which goes on to mean your solar will not be coming into planning during the day because it will help you in shaving off the load in the afternoons. But whosoever feels that capex will come down because of solar penetration and EV markets balancing each of them out, are in for a big shock. That's not going to happen. Therefore, your distribution network planning, this is the network, this is the analysis. A connection comes from the consumer. If in case it's up to 10 kilowatts, it gets engineering processing is done online. Nothing to do. You just put in the pole number of the consumer and the job is done. But paperwork, once again, whether he is actually a consumer designate is something that has to be seen. That takes time. Here is the network planning. Last slide for us. Let me run this through. The 11 kV data is taken from ADMS that we have. Along with that, your site inspections are all done. The mitigation options are checked. DT loading is done. Now, with DT loading, where do you put in your solar? Our advice is do not put it in if in case you are looking for an industrial, residential, or a commercial consumer who needs power throughout the day. Put it in only when you have a consumer who addresses your unimodal peak of the afternoon. That being said, I think time is less. I will not go any further, sir. But grid storage, our grid storages are largely based on our battery chemistries are lithium, nickel, manganese, cobalt oxide. 10 MVA has been put up, and this is how we are doing it. It was costly when we built it, but presently it's much cheaper across India, and it makes sense to have it. And that asset will sweat itself off. If in case you are looking for an integrated local energy storage system, when you want to drain your batteries, you charge it. When you want to drain it, is something, as sir was saying, will be driven by the market. But what happens if in case you have a power failure at that point of time? Will money rule the business or will the network constraints do it? I'm an engineer. I would like to believe that consumer has to be served, especially other than peak period supply. If in case there is a failure, fault, at that point of time, batteries come in very handy. That's how things are. Entire connectivity, given the capabilities that India has developed, and it's available across globe. The computational facilities, the communication facilities, you name a design. If in case of the cost, intent, and time, it will be done. That is the cusp where we stand. Many more business cases will come, and we will go on to implement it. Benchmarking, yes, we are in the top 25. We will break into the top 20 very soon. Rather, this year's results, we are waiting for them. That's it from our side, sir. Thank you.
Thank you very much. We are completely out of time. I would request the Honorable Chair to give his concluding remarks. All questions offline, or you can send the emails to us.
So, thank you very much, the esteemed panelists over here, and the August gathering over here for being patiently listening to all of us, though we have overstepped the time a bit. Uh, I think we ran a little short of time, so we are not been able to take the questions. Uh, if it is possible, can you just mail your questions, because we can meet.
One question.
Sir, my name is Giri Sethi. I have two, three questions.
Sir,
Hello, hello, hello. Yeah, now it's working. What about the state government? They are giving the some units like 200 units free of subsidies. Yeah. What about the state governments? They are giving free subsidies of 200 units or maybe 100 units or maybe 300 units. Then
That's not in the purview of this panel. We are
Okay,
talking about
okay,
technology,
okay.
subsidy, and other things. Other panels are there. You can talk to them. Thank you. Please.
Just one question, last question. There should be a non-financial audit should be there.
We are not going to discuss about that.
We have what we have discussed over here is about the smart distribution system and the technological interventions, right? So, in case there are separate questions which are not related
The
to
cyber
this,
security, like Mr. Amarji said, it's very important.
yeah, that's
Hacking,
see, he has highlighted that. That's what I'm saying. My request is please put your question on a mail to us and you'll get the reply. We are running short of time. So thank you very much, everybody. And I thank all the panelists over here. Though we have been a little catching up with the time for them. So I think we have not been able to do entire justice with them, the knowledge they have. But definitely they are all available. And I have Mr. Pillai with me. So he's I would say he's a knowledge bank, so you can always contact us anytime, and thank you very much for being here. Thank you.
Thank you very much indeed, sir. And I would request Sri Hemant Jain sir to kindly do the honors of presenting mementos as a token of gratitude and appreciation. We begin with our moderator, Sri Reggie Kumar Pillai. I would request you, sir, to kindly do the honors. Hemant Jain sir to kindly present to our moderator. Okay. I would request Reggie sir to do the honors. To Shri Puneet Dubey sir, Director Technical, Madhya Pradesh Kshetra Vidyut Vitran Company Limited. To Shri Anil Rawal, Managing Director, IntelliSmart Infrastructure. To Shri Puneet Chabra, LTech Inc., USA. To Shri Amarjeet Kumar, India Representative, Vice Sun Alliance. To Shri Ravindra Desai, Program Manager, IEEE ISGF. To Shri Pramod Mishra, AVP, Head Distribution Planning, BRPL. And to Shri Subhadeep Ray Chaudhary, Head Engineering, TPDDL. And I would request Shri Hemant Jain sir to kindly present to our moderator, Shri Reggie Kumar Pillai sir. And I would request for a quick group photograph of the esteemed panel. Ladies and gentlemen, we would request everyone to kindly remain seated as we are straight away moving into the next session, which is session 9. The session 9 is on the role of green hydrogen and derivatives in India Net Zero Future Vision 2047. We would request everybody to kindly remain seated. Just give us few minutes while we arrange the top table for the next session. And while we are arranging the stage for the next session, I have an announcement to make. All the delegates would be having a badge looking like this in the delegate kit.